So last video we spoke about functions. Now we're going to speak about classes. A class is a way of organizing objects. All programming is, it's about manipulating data. So in the past what we've done is we've been manipulating very small pieces of data in variables. We've just been storing numbers or strings or maybe lists of people and things like that. But now we're going to start storing more elaborate objects and more like elaborate pieces of things that are connected. For example, if I have a student, they'd have a name and student ID and an age and the classes they're registered in. And then those classes would have lists of students and they would have professors, and I want to be able to add and remove students from a class and the class when it's scheduled and all that fun stuff. I'd want to be able to do a lot of different things with this information. And so what I've got to do is I've got to have a way of managing larger objects, representing larger objects in my program. So we're going to move up from just representing single pieces of data or lists of single pieces of data, which we have our basic data types for, right? Our strings and our ints and our floats and things like that. And we're going to move on to representing bigger objects. And so those objects are, we have a class, which is the generic form of like, hey, I have a car, which is what my example here is. It's a class for a car, which has a make, a model, a year, and some mileage. And I'm going to talk a little bit more about this. And then we're going to have the methods that we do to this car. For example, we can log a trip, which would add to the mileage, for example. Or we want to print out the car, we can format it into a nice string and then print it out. Do those sorts of things. Or we can calculate the value of the car, and we'd have like some way of doing, we'd write a function that had some formula to calculate that. So we're going to begin by just looking at this class. A class, in order to declare a class, you have to write class and then the name of the class, the same way we have to write def and then the name of a function. Classes have a few built-in functions, and you recognize that double underscore from like all the way back at the start when we did our main.py, and we have if name equals main over here, this fun line. That double underscore means it's a built-in feature of Python. And so init is a built-in function that we're overriding. So we have the init function, we're using self, which is whenever we write a function inside of a class, we have to use the word self. That refers to the specific object. And all we're doing here is we're saying, hey, when I create a car, which I'll show you the code to create a car in a minute, I'm going to take a make, model, year, and mileage, and I'm going to set them to, hey, this is self.make, so this is going to be my make, my model, my year, and my mileage. And those attributes are going to be accessible, and I'll show you how we access them in a moment. So let's create the car. So right now our car has nothing to it, but we're going to go from car, right? That's the name of my file. I named my file car as well. And in general, I like to name files after the name of the class in that file. Import car. So now I'm importing my car, and I'm going to go at the bottom. I'm going to say if name, and this is where we start using that syntax again of if name equals main. Then we're going to run a main function. So now we're going to start using functions much more regularly, and you'll see like actual practical uses for them. So def main, and this is my main function, and this is where my program starts. Why don't I just write the code in if name equals main? Because that can sometimes lead to unforeseen circumstances of what's predictable and what's not predictable, of certain unpredictable behaviors. I want to keep everything localized, so I create a main, so I reference a main function and I just write my main function here. So for now we're going to say Lucy equals car, and Lucy is going to be a Ford Mustang from 1967, and it is going to have traveled 50,000 or 57,133 miles. So I have just created a car. The same way the same way that we create other variables. Now I've created some weird variable that is a car. So if I go Lucy, so if we print out Lucy, right now, all that, notice how I don't actually need, notice how I'm not using circle brackets, right? Because this is not a function, this is an object. In the same way, this is a certain amount of data. And so this is just showing us, hey, it's even got a rollover in PyCharm that says, hey, it's a data type of car and it was created using these, like these are the values for its base thing. But if I run my function now, I get back, hey, this is a car.car object, which means it is, and it's at this memory address, which is kind of useless information to us. It just tells me the type of object that it is. It says, hey, that variable is a car, and it's stored at this memory. Now, that's really useful. That's really useless to us because we don't need to know where it's stored or that it's a car. We want to actually get some useful information from it. So if I want to, for example, edit the make, if I want to see the make, I can do I can do Lucy.make, and I run this, and it tells me that it's a Ford. So I can already get some meaningful information about my car by going car dot, so it's object name dot, and then the function that we're using name, or the attribute that we're accessing name. In order to access something inside of a class, that is how we do it. So we are going to create a function that we're actually going to use. So we're going to create the log trip function, right? And this is going to, every function that we create in a class always takes in self. And this is also going to take in length of trip, right? So this is just going to be the length of the trip that we went on. And this is just going to add to the mileage. So we do self dot mileage plus equals length of trip. So all that this function does is it's just a way for us to log trips. Now I want you to notice something when I call this function, right? So I'm going to say a, so we say Lucy dot mileage, and then we say Lucy dot log trip, and we're going to log one for, let's say, 99 miles, and then we say print Lucy dot mileage again. And if I run this function, notice how it added, right? We added 99, so instead of 133, it went up to 232. What's actually happening here is we're calling a function, and since it's we're calling a method, which is a function inside a class, and since it's the function inside the class, it references over here, and it takes this value and it adds it to my mileage. Now, some important thing to realize about our function inside the class is that it references self, right? All of our functions over here reference self. This init function is being called when I create a new car, but automatically it's called when I create a new car, and we just have to create it in order to set the attributes that we want. But notice over here, the log trip, self is referenced. But when I call the function, I don't actually call self, right? When I call over here log trip, I just set a value for length of trip. Why is that? That's because self is the instance of the class, which basically means the class is the idea. The class is, we have this concept of car, and then self is every single car that we make has to store these things in itself. So when we edit the self dot, so when we're editing parts of the self, we need the self, the thing that we're editing, which is a specific car, and the stuff we're doing to it. So how does that make any sense? Let's create another car, and then this will make a little bit more sense. So I have Lucy, and we're going to call this one Jack. We have Lucy and Jack, and I'm going to create another car, and Jack is going to be a Honda Civic from the year 2022, and he's going to have 17 miles on it. All right, and now I'm going to go, and now all we got to do is we're going to print jack.mileage, and we're going to print lucy.mileage. Now, If we run our function again, we've got those two numbers, and that's my starting number for Lucy and my starting number for Jack. And if we do Jack dot, if we take Jack over here and we just say, hey Jack dot log trip, and we're going to say we went 65 miles in Jack, and we run it again. When we print out Jack's mileage, his mileage is now 82, which is 17 plus 65. Cool. So these are two different cars, right? They're still using the same base class of car, but each of them is its own thing, and each of them has a different value for this mileage because they each have their own mileage. But we have to be very careful, because if I don't put this inside if I don't make it about self, then I can make it for total, right? If I put mileage over here, let me say mileage equals 0, and then we're going to take this and we're just going to comment it out, and we're going to go enter because it wants a blank line, and we're just not going to use mileage. So we're going to leave mileage there, so this way it's a thing, and then we do self.mileage. So notice here that we're not actually, and we go, no, we're still going to do self.mileage, but instead of setting it that it initializes and that each one is its own thing, we're setting one generic mileage. What are the implications of that? If I run this now, never mind. We're going to say that, okay, here's what we're going to do to make this mileage plus equals mileage. So what happens here, and never mind. The point I was trying to make, and which I made rather badly, is that each of these classes is its own thing, and it has its own particular attributes. And each of those, it has its own functions and it has its own attributes, and we can create those attributes and edit those attributes. Now, a thing to realize is that numbers are actually objects, and booleans are objects, and strings are all objects. Same for range, right? A range is a kind of object, a list is a kind of object. Everything we've dealt with up to this point is a specific object, right? It's an instance of a class. And that class is going to be whatever the data type is, that's the kind of class it is. In our next lecture, so what we've done so far is we've created a basic class and we've looked at classes a little bit. Now the thing to realize is that things like number and length and string, those have definitions in the class. So if we want to, we can override the default definition of string. So right now, if I print out the word Jack, what happens? Right, if I print out my Jack car, all it does is it prints out the car object. What we're going to talk about in the next lecture is we're going to talk about, or the next video, is we're going to talk about how to take Jack and how to take that string method and make it something unique and useful to our specific class.